let's take a look at force. So first of all, what is force? It's surprisingly difficult to give a good definition. And what I'll do is I'm going to give you 3 definitions, each more complicated than the next. So the first definition that you often hear of force is that it is a push or a pull. And that's a lovely definition because you can imagine what a push or a pull is. But it doesn't really capture everything you need to know about force, so maybe a better definition is it's a push or a pull which can cause an acceleration or deform an object. That's a better definition because, yeah, it's got push or pull, so it's kind of intuitive, but it tells you what a force can do. It can cause an acceleration or it can deform an object. But push or pull is a little limiting, so an even better definition might be it's an interaction which can cause an acceleration or deform an object. And that makes it more general, right? It's not just a push or a pull, it's an interaction. But whatever you define it as, the reason we use force is that force is a useful concept, and it allows us to understand how objects interact to change their motion and the motion of other objects. And it opens up this field called dynamics. Dynamics is the study of why things move, and it will lead us to other concepts like energy and momentum. But force is usually the first step into the world of dynamics. Force is often represented with a capital F, and it has a unit called a newton, capital N. And a newton is equal to a kilogram meter per second squared. Now you might be asking why. Well, don't worry about that. We'll see it later. Force is also a vector, so it has a direction. And the way that we're going to approach force is we're going to think about different types of forces. We're going to put forces into different categories. And the categories aren't perfect, and different people would use different categories, but it's a good way to get started. The forces we're going to look at today are gravitational force, tension force, normal force, and applied force. So let's start with gravitational force. Gravitational force is the attractive force of one mass on another mass. And it's a very big topic. You know, if you think about the Earth and the Moon, there's a gravitational force on the Moon, which is attracting it toward the Earth. And there's a gravitational force on the Earth, which is attracting it to the Moon. For our purposes, we're going to start looking at objects which are near the surface of the Earth. And if objects are near the surface of the Earth, then the gravitational force that we need to pay attention to is the gravitational force that's caused by the Earth. So imagine you have a block on a table. The gravitational force on the block is caused by the Earth. The Earth is attracting the block to it. So the gravitational force that's acting on the block will be toward the center of the Earth. All right. 2 other things about gravitational force. One, we can write down an equation for the gravitational force on an object when it's near the surface of the Earth, and that's Fg is equal to mg. M represents the mass of the object, and g represents the acceleration due to gravity. And near the surface of the Earth, g is equal to 9.8 meters per second squared downward. So that's nice. We have an equation where we can calculate the gravitational force as long as we're near the surface. Also, gravitational force is also known as weight. So this is a little confusing because if you exit the physics classroom and you go out into the world, when people talk about weight, they often mean the same thing as mass. However, in physics, weight means the same thing as gravitational force. Weight is a force in physics. Weight has units of newtons. Mass, on the other hand, has units of kilograms. They're 2 different things. Weight and mass are not the same thing in physics. So keep that in mind. All right, let's think about normal force. So normal force is a force of contact, which is 1, perpendicular to the surface of contact, and 2, away from the object causing the force. Sometimes it's called a reaction force. We'll worry about that a little bit later. But let's look at a situation. Let's think back on that block that's sitting on a table. The block that's sitting on a table is in contact with the table. So there's going to be a normal force because it's in contact with something. And the definition says that the force will be perpendicular to the surface of contact. So, okay, if it's perpendicular to the surface of contact is that surface between the block and the table. And perpendicular to that could either be up or down. Well, the second thing says it's away from the object causing the force. So the object causing the normal force on the block is the table. That's what's in contact with the block. So the normal force has to be away from the table. That means that the normal force on the block is upward. All right, let's look at a different situation. Let's say I have the block on a table, but now I put a second block on top of the first one. Let's think about the normal forces on the first block. Well, there's still a normal force from the table, and that's going to be directed upward away from the table. But now there's also a normal force from the block on top. The block on top is in contact with the block on the bottom, so the block on top is going to exert a normal force on the bottom block. What direction would it be? Well, the surface of contact is right there. It's horizontal. So the normal force would be perpendicular to that and away from the block that's on top. Well, away from the block that's on top would be downward. So there's also a normal force downward on this block. Okay, and just to change our perspective, now let's think about the block that's on the top. Okay, let's think about the forces over there. Well, the block on the top, what's it in contact with? It's in contact with the block beneath it. So the normal force on the block on top would be perpendicular to that surface and away from the object that's in contact. So that would be directly upward. Now, notice that the block on top does not feel a normal force from the table because it's not in contact with the table. Yeah, the table is there, but it's not in contact with the table. A normal force only exists if there's contact between two objects. Now let's think about a last situation. Let's say we have a ramp, and I put a block on the ramp. Okay, what direction would the normal force be? Well, the block is in contact with the ramp, so the normal force would be perpendicular to the surface of contact, so it would be directly away from the ramp at that angle. And in each of these situations, we can also draw the gravitational force in there. That's a little easier. Gravitational force is always directly downward. So we'd have that. All right, now let's take a look at the tension force. The tension force is a force which is applied by a rope or a string or a cable or something of that sort. And tension forces can only pull in the direction of the rope or string or cable or whatever. So I'm going to draw a situation here. Let's say we have a block on a table and there's a string connected to it, like this. Well, the tension force is always in the direction that the string is pulling. So the tension force would be in that direction. Now in this situation we also have a normal force away from the table, and then we have a gravitational force directly down towards the center of the Earth. And I could draw a different situation. Let's say we have a block hanging by a string. Well, then the tension force would be in the direction that the string pulls, which is upward. And there's also a gravitational force, which is directly downward. And then I could imagine a different situation with maybe two strings at different angles like this, and they're holding up a block. Well, then we'd have tension forces in both directions that the strings pull. And then we'd have a gravitational force directly down toward the center of the Earth. And I could keep going. I could make a block on a ramp with a string attached to it, and then we'd have a tension force in the direction of the string, and a normal force perpendicular to the surface of contact and away from the ramp, and a gravitational force directly downward. All right. The last type of force we'll look at today is the applied force. And this is kind of a general term that's used as a catch-all for some force that's being applied to some object. Often it's due to a person. So for instance, if I had a large box and there's a person who's pushing on the box, sometimes we'll call the force that the person is applying to the box the applied force. Or if we have two people and they're pushing on opposite sides of the box like this, we'll refer to the applied forces from each of the people. But just keep in mind, applied force is just kind of a general term that we use about another force, where we don't want to say that it's a normal force, a gravitational force, a tension force, or so on. We just want to talk about another force.